Hello, hello, hello. Welcome back to the channel, welcome back to the stream. Today I will continue in solving the CodinGame puzzles. We are currently at level 6 by gaining experience from the solved puzzles. We'll see how it goes today. Okay. So let's find an interesting one. I've skipped the ASCII art as it seemed not that enjoyable. So what do we have? Logic. Let's try the logic one. Seems like it's gonna be just using the logic operands. Logic. Okay, let's take a look. Let me increase the size. Okay, this could be visible. A logic gate is an electronic device. One or more binary inputs. Okay. N input signal names. So we've got N inputs. And M outputs. Provide M output signal names in their respective data, the same order. Okay. So far I'm fairly confused. All type of gates will always have two inputs and one output. Okay, all input signal data have the same length. Okay. And or XOR NAND NOR and XOR. Okay. Signals are represented with underscore and minus. Underscore is 0, minus is 1. Okay, so we've got the again, what are the numbers? So line 1 is number of input signals. That's 2. M is number of output signals. That's those 3. Two space separated strings. Oh, is it the A? Okay, so A is the name. Then there's the signal. It's N lines, okay. And there's name of the output C, the operand, and the second now the two input signals. Okay. That does not look that enjoyable as well, but let's give it a try. So what do we have here? It's like those are just the numbers. And M. So there's a input counter, output counter, and we are reading the input name, input signal. Okay, so we should store this somewhere, and it seems like a dictionary would be great for this. So let's say we got a dictionary. String. Let's call it ins. Create a new one. And let's do the same for out. Well, it's gonna be slightly different. Okay, so ins. Let's edit there. The key is gonna be the name. And the signal. Okay. So that's the inputs stored. Okay, then we are reading the outputs. They've got a name that we need to output as well, so we need to store that. Output name and a signal. Okay. Then an operator and the inputs, two input signals. Okay, that's the input 1 and 2 and an operand. I mean, we could do a struct to store all of these in another dictionary. Okay, let's try it like that. Can I define my own there? Let's make it probably. Gonna call it data. What are we gonna need? So the operand. Make it public as well. And the two signals. So let's call it just signal 1 and a signal 2. Okay. Then we should create a dictionary of data. And let's store it there. Okay, so out at the name. Now we need to create new instance of this data. So let's just create a constructor. Okay. And then just fill it in. So that's like type. Put name 1, put name 2. Okay. And then we just need to calculate the output. That's the iteration through the outputs, which I don't want. I'm gonna use the for each cycle instead. I mean, you can't iterate through dictionary, right? Okay. Let's just make it a list then. And let's put the name there as well. Okay. So the collection is out. And now let's come up with some magic. And it's gonna be the output. Okay, so first we need to make some kind of switch based on the operand. So this is gonna be this. Let's say it's gonna be, what are the options? And let's start with that. And we should make methods to just output those two. Okay. Let's go down there. And it's gonna output string, and let's call it, I don't know, process, and you're gonna need the signals. yeah. Can we do for each for a string? Not absolutely sure, but let's try. Is it working? It seems like it does. Okay. And since they are ensuring they are the same length, we can just go through both of the strings at once, which is nice. So okay, but we don't have the... Okay, let's do it for cycle. Should be something like this. Okay, now we just have to compare these signals. So if S1 I is the minus as well as the S2, then we are gonna add this, else we should use some kind of string builder and stuff, but I mean, just a few characters, it's not that time costly. I mean, and okay. So this is gonna be like the signal 1, signal 2, object reference is required for the non-static field. Which one? Not sure what they mean. Okay, the main is static. Do we need this? Okay. So this should process the signal for end. But for the result, we also need to add the name of the output. So let's actually put it down there. Name plus a space. Let's do it like that. Okay. This should handle the end input Let's test it with this. It's not found expected. It's interesting. Why wouldn't it continue? I mean, I could debug, but I kind of forgot how to put it in the output. Deleted the code. But it was something like this, right? Not there. Will this work? That's interesting. CLK. What's that? Okay. Seems like there's something very weird stored in the list. Out. name, type, input 1, input 2. Okay, that's really interesting. Hmm. Okay. I mean, is it like a debug? No. Uh, let's copy this, try to restore. And the debug is console error. Console error right line. Okay. Like this. This is gonna be any different. Nope. I really don't get it. Okay, so the list is initialized, so that's okay. It is used only there. And we are adding new data. The name, type, can I debug this then? Okay, it's a string array. It's not what I wanted. Okay, so oh, right. Those are the names of the inputs, right? Okay, sure. So we can't process just the name. We need to get the ints in a picture. Of course, that's why we stored it. So let's do something like this. Obviously. Okay, there we go. Silly me again. I was confused because they are naming it like ABC and then they are using totally different annotations. But okay, up to speed now. Okay, so now we just need to do the other operands. Again, I mean, I'm just gonna do like a separate method for each of them. That's not the most efficient way, but yeah. So let's put an order. No. Okay. Let's try again. Cool. The other one is XOR, which I don't remember the syntax for. And nor. And XOR. Okay. So we need the XOR. The XOR. I need to look it up. So I don't know. C# XOR operator. So XOR is that. Yeah. I thought so. this. Hopefully. Then we've got the NAND. So that's and dot inverted. So can I just do this? Maybe. Nor. Let's actually copy or. And let's again just swap those. And XOR. Okay. Well, let's see. Okay, so far so good. Okay, cool. We delete the error outputs. And let's submit. Yes. Okay, good. Perfect. So, almost level up. Let's pick another one. Something not stringy, please. Parsing, no. Geometry, ASCII art, no. Probability string manipulation. I mean, those are supposed to be easy. Don't. 2D array. Reverse minesweeper. Okay, this could be fun. Given a grid of mine locations where dots are empty cells and X are mines, your goal is to display the grid like it appears if you win the game. Each position is a digit indicating the number of mines bordering it, including diagonals. Okay, that could actually be easy. So, width and height of the array, obviously, width and height, and each line of the mine field with dots or mines. Okay. And I need to output the map. Cool. All right. So now, do we need the array? We might. Let's call it data. It's again the width and height. Never know which one should I put first. Let's try this way. Let's do it like that. Okay. Then that's the line. And expecting age. Okay. Let's actually do it the other way then. We could again go through the line and save the characters. Data. Oh, we need the for each. I mean, for cycle again, right? Okay. Let's call it J. And let's call it line length. J. That's gonna be the line. J. Hopefully, probably, maybe. Okay, so this should store the input map to the data. Let's check that with I'm not sure. Okay, let's try. Let's do this again. This should be W. You can use it there as well. And let's just write this. Okay, this could output the map or not. Line 37. Okay, it does not belong there. Okay, so that's the input map. So now we just have to calculate the actual numbers. So we should just look at the neighboring fields, count up the number of mines. That's just annoying and not difficult. But let's try. Okay. Okay. So first, if the character is not a mine, then we'll take a look at the neighbors. And that's gonna take another 2 for cycles, which is unfortunate. I should make a method for that somewhere. Okay, let's put the data there. We don't. Oh, we can't. Okay. Okay. Oh, so can we have like the, yeah. Okay, cool. 6R. Can I return R? Is there something like to R? No. Oh, Blue Knight, it's I finished the first task. Now I'm working on this one. I know what I need to do, but it's just kind of painful to do. it's too much looping. So I and J, okay. Let's call it, I don't know, M and it's actually gonna be I minus 1, I plus 1, so that should be plus 2. It's gonna start at I minus 1, I plus 1. Okay. It's gonna be J minus 1, J plus 2, and we need some kind of counter. And then if this is mine, gonna increase the counter, and then we need to return the counter, but it should be string, which is not valid. How do you convert from int to char? There's some parse, okay. No. String. Okay. It's never used. It's gonna be used right there. I and J. Okay. Now that's just the problem of it going overboard. So something like if m less than 0, then continue, and if m is bigger than what? H. And this actually needs to be mn or nm. It's a question. Not sure which one stands for which one. So I and J, it's in this order. I and J, because I and J Ah, that's confusing. I hate two-dimensional arrays. So I needs to be less than h. Okay. But which one is m and which one is n? M is for I. Okay. Mm. Let's just say if m is bigger or equal to h, you need to skip. Okay, cool. Let's do the same for this one. That should be w. Okay. I mean, this is not all. Oh, we can't return 0. So it should be like c bigger than 0. Return this. Otherwise, it should be a dot. Okay. And then we need to transform the mines into dots as well. So let's do something like, if it's an X, let's draw dot, otherwise, okay, something like this. I don't know. Let's see. Not optimized, and it's taking too long, of course. Does it? This is just creating the input. Then we are going through each field. When it's not a mine, needs to look at the around bases. Was it really that slow? How can I optimize this? I mean, it shouldn't be that slow. Come on. Must get in stuck somewhere. Can I at least get some results? Nope. Okay. Okay. There's the problem. Okay, cool. Let's see. Perfect. Okay. Submit. Great. Okay, level 7. And 100%. Perfect. Cool. Again, it was a bit different than I expected. But I'm glad been able to finish it. Okay, great. Is there some kind of filter? Nope. Okay. Loops and arrays. Yeah, that's something we've done just now. They've all got like 4 stars. Credit card verifier. Nope. Numbers. Completed by just a few people. So, conditions loop hash tables. Trigonometry. No. This one's got 5 stars as well, so let's just look at it on this side. Card counting, you're playing blackjack, casino. Okay. Stream of consciousness. Stream of consciousness. Let's just take a look at the... Oh, it's the same. Stream of consciousness is what you observe. Each thought or observation separated by a period might be a series of cards, something else. It's a series of cards if it consists solely of valid cards. Okay. Calculate the percentage chance that the value of the next card will be less than the bust threshold. What would make you and go bust by going over 21? Ace has a value of 1. Those are tens, each number. Okay. It isn't anything you need to calculate, it is provided. Okay. Is there like an example? Okay, some distraction. I don't understand it. So what's the input? Examples, okay. A jack, a 10, 7 ace, and 2 fours. Okay. Jake might be your body, but it's not a series of cards since E isn't a valid abbreviation. Okay. So the dots are like separating chunks of data, I guess. Stream of consciousness. That's this. Might be a series of cards. Okay, I get it now. Okay, that's an interesting one. I've got like, I don't know, 30 minutes. Will that be enough? Not sure. Oh, let's try since we've spent time understanding it. Okay, so the bust threshold is it inclusive or exclusive? I don't know, we'll see. And that's the line. Okay. So we can like easily split the stream with the dots and then process the inputs. Okay, finally. Okay, then we should have some kind of memory. I don't know. Should it be dictionary again? Let's do just some things and don't worry about the optimization. Just spit out ideas. We'll see. Could be something like, again, R and let's again call it, I don't know, scene cards. Let's do a for each. Item, okay, ints for each. Item, let's say character in this, okay. We should first validate the item or do I need to initialize some data in there? Not sure. Never mind. Let's first or I could keep making like a superstring. Yeah, it might be a way. Okay. Let's try this. Let's call it clean. It's gonna be like a temporary. And let's do some checks. Well, I'm really not sure how. Is it gonna be a really long if? Why no? So if C I don't know. So if the character is there some kind of, I don't know, enumeration I could use? Something like string valid is KQ JT A and 2, 3, 4, 5, 6, 7, 8, 9. Should be 13, right? Okay. There's something like contains or something like that. Okay, cool. That will help. So let's say if it does not contain this, let's say we're gonna break. That's again more difficult. What I would like to do is just to append this item to the cleaned string. Let's do something like do bool valid is true unless it's not. I don't know. And let's say if valid then clean. Let's add this to the clean. Okay. let's just check things with this. And this is this, right? Let me just see this. So this is the input. This is the cleaned input. It looks okay, I guess. So the first part is done and working. Now we just need to calculate the percentage. Okay. How's it calculated? So there's the bus threshold. And are we talking about just the one card? Can it be multiple? Just one, right? Next card, just one, okay. Value of the next card will be less than this. Okay. I don't think they will be ordered like they are in this case, in every case. So we can't count on that. So let's just yeah, we can just go through those and just value them as they are okay or not. Just compare those two numbers then. I mean, we need to first calculate the remaining cards. Okay. All right. So here comes the dictionary. Let's call it cards left. And let's fill it up. With these. Let's call it cards left at key is gonna be the C and the value is gonna be 4. So that's 4. So that's basically building up the whole deck of cards. We're now gonna reduce those. Like there. With the clean. Let's look for the card. And reduce the amount. Okay. So after this, we've got the cards left. It's making up the deck. And we should go through the left cards and value those if they are above or the threshold. Okay. Value of the next card will be less than the bust threshold. Okay, needs to be less. So the last problem is we have to like translate the card signs to values. But it should be okay. Okay, so now we're gonna again do something like this. Let's do int, I don't know, bust. I don't know, good. Let's go through the deck again. And we need to do what, a switch, I guess. So switch on a yeah, I've got the idea. Okay, let's do the switch, and for the case of okay, can I do multiples there? Or do I have to do it like this? No, I think we need to go. Oh, it could be okay. We'll see. So now, if like the what's it called, bust threshold is bigger than 10, I suppose. Then we will increase the good counter by the amount of cards left in a deck with this. So something like this. Else, let's do the same for the bust counter. Does that make sense? Let's say we've got like 2 kings left. Would work. I don't know. We'll see. Now we just need to do the other cases. So was there ace equals the break. Okay. I'm pretty sure there's gonna be a much cleaner way to do this, but I'm too lazy to think of any right now. Well, I actually just need to do like 2 through 9 right now, right? Oh, there really needs to be a better way. I just really need to convert this into a value that will be placed there. I mean, with a little bit of thinking and time, I'm sure I would come up with something really smart. Well, let's do it the dumb way right now. I don't know, is this going to work? Okay, then the percentage should be rounded somehow. With a percentage sign, okay. So it should just be like cute divided by the bust. With some kind of rounding and stuff. Is it rounded down or the nearest? Rounded to the nearest, okay. Oof, so let's call it chance. Be this. And let's have it like, I don't know, wrong chance. It's still 2. Cute divided by cute plus bust. It's now 1%, okay. Can I get the numbers then. Okay, that does not look correct. Or maybe. Oh, it's actually correct. Right? There's just 2 cards that are good, one's boss. That's 67% actually. So what's wrong there? That's 2 divided by 3. Oh, okay. I need to... Okay. I need to multiply by 100. Okay, perfect. Okay, it was again more stressful than expected, but it's working. This is really ugly. I would come up with a better solution, but since this one is working, I want it to be over. Okay, perfect. Okay, get rid of the... Oh, there's a lot of test cases. Not a chance. Okay. Why is there so many test cases? Well, at least it's working. Okay, submit. Perfect. Run your code 100 times. Okay. So that's another of these tricky tasks done. Thank you for staying and watching. It was a chore, but we've got a couple of them done again. So glad. Thank you for watching, and I will see you soon next time. Thank you. Bye bye.